Hi, it's Paul Andersen, and this is Disciplinary Core Idea ESS1C. It's on the history of planet Earth. And the history of planet Earth is literally written in the rocks. And so if we look at those rocks, these are sedimentary rocks. They're going to be laid down over time. So there's erosion and deposition. And one thing you should understand is that we can learn a sequence from how those rocks are laid down. And so the oldest rocks are going to be laid down first, and then newer rocks are going to be laid down on top of that. But we can have earthquakes and fractures and volcanism, and all of those, if we interpret them correctly, are going to give us a little bit of the history of our planet. What are some other clues we can get? Well, the fossils found within those rocks are going to tell us what life was like at that time, but they're also going to allow us to look at rocks in a certain area and compare those to rocks in a different area. And also we can actually get measures of the rocks. We can look at the radioactive decay of elements within those rocks, and we get a pretty good idea of how old those rocks are. And so there's a huge amount of evidence we can get to the history of Earth. One of the cool things we find is that when you look on the continents, and so it's kind of hard to see this map of the Earth. Here's North America, here's South America right here. One thing we found is that the continents are going to be really, really old, and the oceans are going to be relatively young. And so the oceans are going to be less than 100 million years, and some of them are going to be less than 10 million years old. But if we look on the continents, they're going to be sometimes billions of years old. We're going to have some rocks in Montana that are almost 4 billion years old. That means those rocks go back to the formation of the Earth itself. And so one thing you should understand is that the Earth is not static. It's incredibly dynamic. It's shifting all the time. And so one of the best explanations for that is plate tectonics. And so all of these continents and oceans are these giant plates that are constantly shifting on top of the mantle. The surface of the Earth, even though it's cooled down and it's not moving, we're going to have erosion on the surface. We're going to have volcanism where we're building up new land as well. And so the Earth is incredibly dynamic in nature. And so it's hard to look at the Earth and figure out, where is the evidence on the Earth? And so what happened in those early formation of the Earth? And so one way to figure that out is to actually look to space. And so we can look to asteroids or things that have fallen to Earth. And this is a meteorite right here. And that tells us more what the Earth was like in its earliest days. And we can also look out at other planets. We can look elsewhere in the solar system, and it tells us a little bit more of what happened on our planet. And so if you look at the moon, you see it's just littered with craters. Well, our planet has been hit by just as many things, and we should have just as many craters, but that erosion is clearing it up. And so we get lots of evidence at least the dynamics of our Earth and how it's changing. And we start to come up with a picture of the Earth's history. And so we have to really deal in really, really long time to understand this. And so we think that the Earth is around 4.6 billion years old. And this first period of time, it was mostly molten. We hadn't cooled to the point where anything could be on its surface. But we have these periods of time. And so we have massive bombardment of our planet. We start to get an appreciable atmosphere, and humans show up, look at this, way up here, so way, way later. And so the Earth has been around for a long time, and each of these divisions are really divisions of life. We look at the fossil evidence and where we had massive extinctions and where we had new adaptive radiation of new organisms, and then we kind of get a picture of the life. So that's getting into a little bit more depth. So where do you teach this, or how do you teach this? In the lower elementary grades, you want to give your students this information that events can occur in cycles, like the daily cycles of day and night and day and night, and then we can have other events that just have a beginning and an end. So like a volcano, it starts, there's an eruption, and then it ends. And also you want to have them understand the idea of time scale, that we can have events that are really, really short. So what's an Earth event that's short? Like an earthquake, it's going to occur really, really quickly, and then we can have long events. And so the Grand Canyon was carved out by the Colorado River over millions of years of time. And so that slow erosion takes a huge amount of time. Likewise, all of this rock being laid down took a long time as well. As you move into the upper elementary grades, you want to talk about the dynamics of the Earth and how it's constantly changing. And some of those events could be erosion. Some of those events could be, building up of the Earth, like through volcanism, tearing down of the Earth as well. And so since it's so dynamic, where do we look for evidence of what's going on? Well, we look again into the Earth itself. We want to dig down. We want to look at what the Earth looked like over time. We can use fossil evidence, remember, to figure out what happened at given periods of time. We can even use tree rings to figure out what was happening at different time periods. And then ice cores from Antarctica, from Greenland. We can dig down, and what you get are not only telling us how much ice was laid down during different periods of time, but we can actually collect bubbles from this, so it tells us what the atmosphere looked like during different periods of time. As we move into middle school, we want to talk about this history of the Earth, how long it is, and how do we know some of these things? So we could use fossil evidence to figure out how old these things are. We call that relative dating because we're comparing fossils in one area to fossils in another area. But we don't have a specific time period, and we want to talk more about that, or absolute dating, as students move into high school. And so radioactive decay, in other words, as lead decays down into, so lead-212 down into lead-208, we can measure the amounts of that, and that's going to tell us how long it's been since these started to decay. A really good one when we're looking at rocks is uranium-lead. As uranium is breaking down into lead, it has a half-life of billions of years, and so we can use that to measure the age of these rocks, which are incredibly old. And what we find are these patterns, the idea that the continents are really, really old, the oceans are incredibly young, and that'll become more important as we get into plate tectonics. And where else can we look on our planet for history of Earth? Remember, anything that falls to our planet, like this meteorite, is going to give us evidence about what it used to look like. And I hope that was helpful.